Python. Computers can't actually understand English. And yeah, that sounds strange because everything you interact with, your startup menu, your web browser, every app on your PC is written in English. But underneath all of that, a computer only understands one thing: binary. Just long strings of ones and zeros. That's it. That's the only language it actually speaks. In the early days of computing, this was a massive problem. If you want to display the word hello on computer screen, you'd have to manually write something like this. And that's just 5 letters. Now imagine writing an entire program like that. On top of it, binary leaves zero room for mistakes. Misplace a single 1 or 0, and the entire program breaks. Clearly, a better way to talk to computers was needed. Grace Hopper had an idea. Instead of manually translating every single instruction into binary, why not create something that does the translation automatically? A program that takes simple, readable instructions and converts them into binary for you. That idea became the compiler, a middleman that will understand English and tell computer what to do in binary. And the set of rules of how humans will communicate with compiler became a programming language. Dozens of programming languages exist today for different compilers and purposes. The most common of them is Python. Python was released in 1991, and its whole goal was to make code read like plain English. That's the reason Python became the go-to first language for almost everyone. Schools use it to teach programming, and most learn-to-code courses start here before anywhere else. But don't let the simplicity fool you. Python is the main language behind AI and machine learning tools like ChatGPT. And most of the AI models you hear about are built and trained using Python. Instagram's backend runs on it. Spotify uses it for backend services and data analysis. Even NASA uses it for scientific computing. Its biggest strength is its libraries. Pre-built code for almost anything you want to build, so you're rarely starting from scratch. It's also completely free and open source, and it runs on basically everything: Windows, Mac OS, Linux, you name it. But here's the trade-off. Python is an interpreted language, meaning it translates code line by line instead of converting it all to machine code at once like some other languages do. That makes it noticeably slower than something like C++ or Rust, which is why you won't see AAA games or high-frequency trading systems built directly in Python. JavaScript. JavaScript was created in 1995 by Brendan Eich, and he built it in just 10 days while working at Netscape. Back then, websites were basically just static documents. You'd load a page, read it, and that was it. Nothing moved. Nothing responded to you. JavaScript changed that completely. It's what allows buttons to react when you click them, menus to slide open, forms to check your input instantly, and pages to update content without needing a full reload. It's also the only language every web browser understands natively, which is why it became unavoidable. If you're building anything for the web, you're using JavaScript. With the help of Node.js, developers could now run JavaScript outside the browser entirely, which meant it could also power servers and backend systems. This is what lured in companies like Netflix and PayPal to use JavaScript on both their websites and their backend infrastructure. The only problem is consistency. Because JavaScript runs in so many different environments and browsers, code that works perfectly in one place can behave slightly differently in another, which is why developers often rely on extra tools just to keep things predictable across platforms. JavaScript is easy to get started with, but it is notoriously difficult to master. Yet, it remains one of the most widely used languages on the planet, Java. Java and JavaScript are entirely different programming languages that serve distinct purposes, share almost no technical architecture, and only have similar names due to a 1990s marketing campaign. Before Java came along, languages like C and C++ made things complicated. If you wanted your program to run on Windows, Mac, and Linux, you had to build a separate version for each one. And if a company added a new type of computer to their setup, they'd often have to rebuild the whole program just to make it work there. Then, in 1995, James Gosling and his team at Sun Microsystems released Java, with Wara philosophy, meaning code written on one type of computer could run on pretty much any other device without changes. It pulled this off using something called the Java Virtual Machine. This made Java essential for cross-platform software. Banks, airlines, and government systems still run huge portions of their infrastructure on. It's also the original language Android apps were built in. The downside is that Java can feel heavier compared to something like Python. You have to write more code just to get simple things done, and that extra structure, while great for huge enterprise systems, can feel like overkill for smaller, quick projects. C was created in 1972 by Dennis Ritchie at Bell Labs, and it's one of the most influential languages ever made. A huge chunk of modern programming languages, including C++, C#, and Java, were directly inspired by it. C was built to be fast and to give programmers direct control over the computer's hardware, especially memory. This closeness to the hardware is exactly why C became the language behind operating systems themselves. Windows, Linux, and macOS all have C at their core, and it's still the go-to choice for things like embedded systems, the tiny bits of software running inside microwaves, routers, and cars' ECU. The trade-off is that C doesn't like humans at all. There's no built-in safety net stopping you from making mistakes with memory, so bugs can be harder to track down compared to more modern languages. It's also more time-consuming to write, since you have to manage details that newer languages now handle automatically. C++. In 1985, C++ was released. It was an upgraded version of C language, adding a new way of organizing code called object-oriented programming, which makes large, complex programs much easier to manage. This mix of raw speed and better structure is why C++ became the backbone of the gaming industry. Engines like Unreal Engine are built in C++, and most AAA titles rely on it to squeeze maximum performance out of your hardware. The trade-off is complexity. Like C, it gives you deep control over memory, which means more room for mistakes and a steeper learning curve. C#. C# is the Microsoft's answer to Java, a language built to run smoothly across Microsoft's ecosystem. It became the go-to language for Windows desktop apps, and later, thanks to Unity, one of the most widely used languages in game development, along with C++. Like Java, C# runs inside its own environment called the .NET runtime, which handles memory automatically, making it easier to work with than C++. The trade-off is that it's closely tied to Microsoft's ecosystem, feeling most at home on Windows or in Unity. Swift. For years, Apple used a language called Objective-C to build its software and apps. It was slow and clunkier for modern standards. So, in 2014, Apple created Swift, a language that felt modern, safer, and much easier to read than Objective-C without sacrificing the performance Apple's apps needed. It quickly became the standard for building iOS and macOS apps, and even parts of Apple's own operating systems now rely on Swift. Being an Apple thing, Swift is mostly locked into Apple's ecosystem, unlike Python or JavaScript, which run almost anywhere. However, if your goal is building apps for Apple devices, Swift is pretty much the only language you'll seriously need to learn. Rust. Rust started as a personal project by Graydon Hoare in 2006, before Mozilla picked it up and helped shape it into a full language, with the first stable version releasing in 2015. Its whole goal was to fix one of programming's oldest problems: memory bugs. Languages like C and C++ give you full control over memory, but that same control makes it easy to create serious bugs and security vulnerabilities. Rust introduced a system called ownership, which checks your code for memory mistakes before the program even runs. What makes this impressive is that Rust does this without sacrificing speed, performing close to C and C++, but with far fewer risks. That's why Mozilla used it to rebuild parts of Firefox, Discord uses it in its backend, and even Microsoft and Google have started rewriting pieces of Windows and Android in Rust. But its strict memory rules paired with steep learning curve can feel frustrating for beginners. Lua. Unlike most languages on this list, Lua was never really meant to run on its own. Instead, it's designed to be dropped into bigger applications and used for scripting specific behavior, while the heavy lifting is handled by the host program itself. This is exactly why it became huge in gaming. World of Warcraft, Roblox, Garry's Mod all rely on it for custom content. Its biggest strength is how small and fast it is. Lua has a tiny footprint, barely takes up any space, and runs efficiently, which is exactly what you want when you're embedding a language inside something else rather than running it standalone. The trade-off is that Lua isn't built for building full applications on its own. It really shines only when paired with a bigger system around it. If you found this helpful, subscribe. Let me know what you want to see next, and we'll break that down just as simply.